dig into. So yeah, let me just share my screen. Cool. So I do apologize if I go into full screen and keep having to jump out. I don't think you guys can see it, but there's a button here where I have to keep pressing to admit people in. So I'll try and not make it too jolty. But what we're here today to do is to find out, like I said, how to get hired in AI and data. This is meant to be a session on what you need to know. Excuse me. Cool. So what do you need to know about that? The first thing I think is really important to start with is that from everything I've learned, the getting hired is really a function of two things. So the obvious one is the skills, and the less obvious one is the recognition. If you have both of these things, then it's going to increase your chance of getting hired. If you can do all of the if you have all the skills, which these teams are really using to put AI into the real world, obviously that makes you a more attractive candidate. And if you have all of them, but you have no recognition, well, then nobody's going to know how great you are. So you need the recognition as well, and that kind of comes in the form of making sure that you're out there online where people can find you. And so we're basically going to talk through each of these different components, and I'll try and share kind of the learnings which we've gathered together from talking to a bunch of people and also getting a lot of people hired in the industry. So yeah, getting hired is a function of two things. We're going to talk about them one by one. Firstly, the skills, and then the recognition. So to start with the skills, I just want to kind of clarify a few things to start with, a few common misconceptions. The first one being, I know pandas and NumPy really well. I'm ready for this. But there's a lot more to it than that. I hear a lot of people say that, but really kind of there's a lot that goes into putting AI into the real world. It is not just about using these two Python libraries to kind of do some data cleaning or do some math, because obviously that doesn't make it into a whole product. And really the goal of all these teams in the real world is to make real products. So a second misconception is, I just did Andrew Ng's course on machine learning on Coursera. I'm ready. But I remember thinking that too. And it is, don't get me wrong, a great introduction to machine learning, but there is a lot of focus on a lot of things which are not at all used in the real world. And again, that is just a small component, mainly focused on the modeling, which is just one piece of what it takes to put AI into the real world. So I'm gonna kind of talk about what the other components are shortly. There's another misconception which actually really breaks my heart to see it, but I just want to share it with you guys. But that is, I just finished my PhD. I'm ready. And the thing which is really, kind of quite upsetting about this one is that having done a PhD or going to do a PhD can actually make you a less attractive candidate for getting into into roles in industry. And purely because, what comes with that is the impression that you're very specific, maybe overly specific on, something which may not be it may not revolve around the problem which companies are trying to face. But not like it's a problem, just like it's not the solution to your problem. So if you've got a PhD, that's certainly not a problem that can't be fixed, but it's not the solution to kind of launching your career in AI. And kind of, just to back that up, it's not a problem. Like, we've helped like a bunch of people with who've come fresh out of PhDs to join AI Core and then landed them jobs in the industry. So nothing to worry about. But it is kind of sad, and it's a bit of a letdown of the education system, I think. So we're trying to do something about that. So another thing I want to mention is that you guys may not be aware that the data scientist is not the only role in the group of roles that are required to put AI into the real world. So what skills are companies really looking for? If it's not just NumPy, Pandas, Coursera certificate, and a PhD, and looking for a data scientist role, what actually is it? So I just want to go over the very basics, really, to start with. And so these are some of the things which you really got to be confident with. You got to have have a lot of experience with them to be part of one of these teams. So to start with, Python. So Python is a programming language, the most commonly used programming language for data science and similar kind of automation or scripting, that kind of thing. Jupyter notebooks are a file type which you can run Python in kind of block by block rather than all at once, and also include kind of markdown describing what is the problem, visualizations, and that kind of thing, which you can actually present to people. So being comfortable with those file types, how to use them, that's really key. Another one is the command line. So you should be able to use the terminal on your computer. You should understand that that is just a way for you as a human to talk to the operating system and know a few particular commands from that. So you need some familiarity with that. You'll also need to be very comfortable with Git and GitHub. So Git is a version control software. That means when you change your code as you develop it, you can checkpoint it and always refer back to kind of those iterative pieces of progress. It also means if you enter some code that actually doesn't work, then it's actually not a problem. Sorry, I'm just going to go out and let more people in. It's not a problem because you can always revert back to your previous checkpoint. And GitHub, as you guys have probably heard, is a website where you can upload your code to so that everybody can see it. And that allows collaboration on software projects. So basically every company that has anything other than an infantile data team is and you're definitely going to need to be able to use that to collaborate with other people on software. And just a bit more specifics, you'll need to know how to make pull requests. I know a lot of people know the basics of how to use GitHub, but they don't know how to make a pull request. So that's really pair programming is surprisingly, is something I was really surprised by, is actually done a lot in industry. So not just programming individually, but being able to work alongside someone, commonly in the setting of one of you being like the driver and the other being the navigator, the driver writing the code and the navigator kind of explaining the thought process, and whilst they discuss sort of like what the approach is. That way people get to learn from each other. So yeah, it's really key to practice that. Along similar lines, kind of communication skills are really key, especially in positions like data science, where you might actually have to present technical concepts to non-technical people. Have some degree of stakeholder management, which requires you to be able to explain complicated things very clearly, and understand, how do I present myself, how do I present my work, and similar kind of skills. A final one, which kind of I think always slips under the radar and is never elsewhere like explicitly taught, is reading documentation. A key skill in programming is being able to understand, like, how do I learn more for myself? And so being able to read online documentation is super useful, and it's something kind of that's so commonly needed. It should definitely be taught. Just like nobody teaches email, but how many times, how often are people dependent on email? It's one of those things where it's just a tool which kind of sets you up to do loads of other stuff. So that's the basics really to start with. But to get into more of the details, what I'm going to break down is the key roles that are involved in putting AI into the real world. So just to start with, I'll go over these two disclaimers at the bottom. So the industry is really immature. So the names of these roles are probably subject to change and are commonly misused. And similarly, lots of the skills that I'm going to talk about, they overlap between different roles, especially for smaller companies where there might just be one data person doing the whole stack. And kind of further to those points, some of the things which I will point out are, they might switch between roles. For example, both data scientists and ML engineers might be doing some modeling. Okay, cool. So those roles which I am talking about, or at least kind of what my understanding of breakdown, which makes sense, is these four roles. So data engineering, data science, ML engineering, and then MLOps. And we'll walk through them and explain what are each of their responsibilities and what are some of the most common tools used to fulfill those responsibilities. Just before I get on to kind of going through those roles as well, another disclaimer is that a lot of the technologies which I'm going to talk about are cloud service provider technologies. And I'm only going to talk about one cloud service provider, that is Amazon Web Services. So whenever I say, or you see AWS, just know that if you don't use that cloud platform, there will be an analogous service in a different platform. So maybe a company that you find you're interested in uses GCP, Google Cloud Platform. There will certainly be an alternative version of the tool which I'm talking about.
Harry.
Yeah, is that a question?
Yeah. Do you mind muting all of us? There's just some noise coming through.
Sorry, let me know who it was.
Oh, I'm not sure. Just
okay, I'll keep.
Isn't there a function to mute everyone?
Yeah.
From keys, is it? Yeah.
Okay, there you go. So yeah, so they're the key roles. I hope that makes sense. Again, guys, if there's any questions, I'm really happy to stop and take some time to go through things. We've only been going for 15 minutes. I'm almost halfway done, so we probably won't take that long today. Otherwise, I will keep going. So this is kind of maybe an overview of what some of those roles might contain. You can see it kind of cascades. So in the columns, we've got from data engineer to data scientist, ML engineer to MLOps engineer. And then in each of the rows, kind of some of the roles which they might be responsible for. You can kind of get an idea here that data engineering is at like the kind of the beginning of the stack. That's like, well, we need the data to even start working on the problem. Data science, then kind of like, on top of that, taking the data from data engineers, ML engineers, doing some of what data scientists will do, but then also kind of trying to productionize and scale stuff. And then ML ops engineers kind of managing infrastructure and also kind of monitoring deployment and continuous integration, deployment and testing. So I'll just leave that up for a sec and give you guys a chance to take that in. As I mentioned, no strict boundaries as the industry is rather immature, and responsibilities may vary between companies and roles. So yeah, when I say the industry is really immature, just like what I mean by that as well is within the AI stack, there is a lot of places where it's a battle for what is going to become the industry standard, particularly in ML engineering and ML ops. It's questionable which tools and which companies are going to win. So that's what I mean by the industry is rather immature in terms of the tooling, and the industry is also rather immature in terms of the naming of the roles and the responsibilities of the roles. So obviously, kind of machine learning has been booming, and AI has made rapid progress more and more. in the most recent years than ever before. And so this stuff is really coming to the forefront very quickly. And, obviously big companies are some of the best to actually benefit from the use of AI technologies. But, being a big company means that there's a lot of kind of maybe management and leadership positions who might have been there for years, and they might not have a good idea of what it means to do any of these roles. So there may be some kind of confusion within companies about, what's the right name for this job? Is it a data engineer? Is it an ML engineer? Is it an AI engineer? Is it a data analyst? Because it's kind of challenging to understand, what do these people do? Not many people, like I've done, have gone and talked to a lot of different people throughout the sector. So, for example, I spoke to someone and their title was AI engineer. It turns out they're more of a data analyst, and I really would not be surprised that this is happening across the board. I've spoken to many more people who I personally think they've got the wrong title. And this might be because companies want to capitalize on the hype. It might be because they want to pay these people more for some reason. It might be because they just don't know. So I'm going to move on. Hope you guys have taken that in. The first thing I want to talk about is data engineering. So this is the role responsible for maybe collecting data, pulling it in from different sources, whether that be an app or whether that be from kind of existing APIs, or maybe it's from your own employees on the ground, that sort of thing. Bringing data together and then storing it in the correct format, in the correct place, maybe in the cloud. And yeah, making that accessible to other people is something that I should say on that point. Kind of making sure that, can the data science team access all the data? Can the data analysis team access all the data? Can the kind of the next part of the product access this data so that it can do its function? Data engineer may also need to be able to query data to kind of explore it a little, although that's also something which data scientists would be doing. Maybe what would be useful actually is if I jump between the responsibilities and tools as I go. So collecting the data, choosing what data format that you should take. There's many different formats that you should know about, including JSON files, JavaScript object notation files, CSV files, comma separated value files, and Parquet files for big data. And then kind of along the lines of storing data, you kind of have the choice here between data lakes and data warehouses. So data lakes for storing unstructured data, maybe with less analytical power on top, and then data warehouses for storing very structured data, which allow you to do analysis on top. Each of them have benefits, but also drawbacks. So depending which one you want to go for, really depends on your application. And yeah, two examples of services which might be or are commonly used in industry right there would be Amazon Web Services S3, simple storage service for data lake storage, and then maybe AWS RDS, relational database service for data warehousing. Querying data basically everywhere is going to be SQL, structured query language. Was that a question? No. Cool. And then, yeah, and then also kind of similar to querying data, but maybe just kind of processing data, pre-processing, that kind of thing. PySpark is used everywhere, so it's a Python library. It's a Python library for distributed computing. So if you have a huge data set, you can't process it all on one computer within a reasonable time. You might split it up into thousands of computers and do the operations in parallel. One of the responsibilities is cleaning data. That's something that you might use PySpark for. So transforming many different examples of data. And Python, use their pandas library and similar tools. The command line interface, not so much for cleaning data, but for this thing I've got on the left called ETL. So ETL stands for extract, transform, and load. So the common case might be that you have a lot of data in a big file structure somewhere. It's not very well kind of organized, so it's in a data lake like S3, for example. And what you want to do now is you want to prepare that raw data format for a particular task. Now, the reason you might have stored all of that raw data kind of as in its format as is because you don't know what kind of problems you want to solve with it later. So, so what you would do is kind of just store all the information, and then when you have a problem, you might have a better idea of, okay, specifically, these are the features of each example that I want. So you would basically perform this process of ETL, extract, transform, and load the data into a new format. Extract it from the data lake, transform it by cleaning it or creating certain features from combinations of others, for example, by multiplying them or whatever, or calculating a time difference, that kind of thing, and then load it into a new data format, potentially load it into a data warehouse, like a database, so that it's ready to use for that task. And that's the kind of thing where you might be using the command line interface. Another tool which can be used for ETL is Databricks. So Databricks is the kind of, they call themselves the AI and data platform, and you can use PySpark really easily within Databricks. And another responsibility would be to version data for the data engineer. So make sure that kind of we know what data we had when, so we can revert back to it if we need, or we can see what data caused a certain output. And Databricks is one service that also allows you to do that. It's commonly used in the industry. Another responsibility of data engineering is setting up cloud resources like database services, like those AWS services I mentioned, or maybe Snowflake is another option, which is another database service. Cool. So that's basically kind of overview of some of the key points of what data engineering looks like. So I hope that clears up maybe some misconceptions or some mystery about what it actually means to do data engineering. I'll just pause for a minute if there's any questions about that. I can get a drink as well.
For me, more of a comment. Just I appreciate how you articulated it. Thanks for that. And it kind of makes sense now, especially with the tick boxes that you had in this slide before. Really kind of differentiates what's involved in each one. So thanks for that.
Oh, it's my pleasure. It's exactly what I hope for you guys to get out of this event, because I know it can be it can just be like a huge mystery of like, what does it even mean to do data science? You know, it could mean anything. So yeah, thanks for that. It means a lot.
Sorry,
Hey, Alex.
Is there a data analyst role, or sometimes that pops up and it just
that's a great point to raise. So the four roles that I've highlighted are really like kind of maybe the core thread of what you might need, or maybe just one way to characterize the set of people that you need to do this. And I actually had a conversation with somebody earlier who said, you're missing two roles. He said one of them was a data analyst, so spot on, and the other was a project manager. So I don't have those two in there, but I also think kind of project manager is maybe like a bit of a different thing. It's organizing the people who do these roles. But the data analyst, for me, kind of most of it, or at least what I'm focused on, is captured within the data science role here. But yeah, so to kind of talk more to what a data analyst would do is they would perhaps they'd access the databases created by a data engineer using SQL, and they probably kind of maybe use Python to perform some analysis, maybe to kind of engineer particular features or particular things they want to look at, and then use some software, something like Tableau, to create dashboards and to basically try and better understand the processes and kind of funnels, etc., within the business using that. So yeah, that's a great point. Thanks, Alex.
Hi, I have a question. How would you rate our program compared to Python?
How would I rate what compared to Python?
Our program.
I mean, So basically, like, Python is a safe bet. If you want to learn a programming language, like, you should learn Python, just because it's it's universally accepted. R is another language with similar capabilities, which will do you good applying for some jobs. Some companies are happy using R. In a lot of cases, I think data scientists have the option to choose between using R and using Python. For example, I have a friend at ASOS who told me that's the case there. Yeah, so kind of it can play to your strength if you have that you can do R, but if you have an option between which language to learn, you should definitely learn Python, because Python allows you to do it's becoming the de facto language for kind of data science and data engineering, purely because, as you probably know, there's a huge community of developers behind Python, basically developing new libraries, particularly data engineering, data science, machine learning libraries. If you want to do anything deep learning or like proper AI, then really the only option there is to use Python and to use TensorFlow or PyTorch, which will be in Python. Another good question. And another kind of similar option. Kind of, you could ask the same question about Scala, another language, which again is like some companies use it, but it won't do you any good at others. I have some notes on which companies use that as well. I might be able to share if anybody's interested, so let me know. Great question. Is there anything else you want to talk about that? Cool. Let's keep going then. So
there's some questions in the chat. Sorry.
Oh, is there? Thanks. Let me just
yeah.
get that. Really strange. I can't see my mouse when I'm zoomed in. Could I mute everyone? Yes. How would you compare Python versus Julia? Julia has recently got a lot of attention. I haven't heard of it, so not that much attention. Python is much more widely used and accepted in parts of this pipeline that I'm talking about. Haven't actually heard anybody mention that of all the conversations I've had. What's your opinion on Python? What's your opinion on Python ORM replacing SQL language? Haven't heard of ORM either. I think kind of the query language is another battleground, but SQL is definitely becoming the standard. Cool. Yeah, thanks Prashant for kind of helping me out with that. Python's dominated the market, exactly. Great, cool. So let's keep going. So data science responsibilities here: kind of understand the data, take the data from data engineer, whatever source you have, and better understand it. You can use tools like SQL to query that and figure out things about it, and pandas to kind of, which is a Python library. SQL is its own language. Pandas is a Python library, which you can do things like data cleaning. What else? Like, yeah, kind of feature engineering and that sort of thing. And obviously those things can help you understand your data. Another way to understand your data is to visualize it. So make sure a data scientist should make sure that they can use some visualization library. Plotly or Seaborn, they're both Python libraries, which I've mentioned, which would be appropriate kind of tools to develop in this case. Data scientists are going to be creating data sets and creating features. And the point of what they're going to do with that is to try and model relationships in the data. So given that we have some particular information, maybe we know what movies a particular user likes, can we figure out other things? Can we figure out what other movies they might like? So, we might gather a lot of raw data, maybe not all of that's useful. We've got to engineer which are the correct features, which are actually going to be predictive of the kind of the thing which we want to find out. So that's kind of creating data sets, engineering features. And to get to the modeling, everyone, I guess not everyone, but like a lot of people jump straight to thinking that modeling means using machine learning algorithms. But a big part of what a good data scientist can do is to understand when not to use machine learning modeling, because it may not be necessary to solve the problem that you want. So one example I like of this is if you use Gmail, you'll notice if you write I've attached in your email and then you don't actually add an attachment, you'll realize that it pops up with a window saying, hey, it looks like you tried to add an attachment, but you haven't added one yet. And so kind of put yourself in the position of the developers who were making this, right? And apparently this is the story about how it went down, which is that they got together and they said, okay, cool, we got to detect if somebody wants to add an attachment to their email. So we can get out the latest transformer model. We can use BERT to encode the sentence representations and figure out the intent of the user and all this kind of stuff. And then someone came up with the idea, why don't we just check if they've said attached in the email and simply check for that, right? And that's the current solution, which is deployed right now. So there are a lot of kind of problems where it's easy to jump in and be like, I'm going to use a neural network to solve this problem, but that's not really what it's about a lot of the time. So understanding when and when not to use machine learning for modeling some problem is a key skill. However, a lot of the times, and kind of to a lot of effect, machine learning is useful for modeling data. So to do machine learning, depends on having some skill in linear algebra, calculus, and statistics. Not like it's not like it's make or break. Not like you need a PhD or even a bachelor's degree in maths to do this stuff. But just like you need to be able to understand the maths so that you can best evaluate what's the right approach here. Should I use model? Should I use an SVM or should I use a random forest? That kind of thing. Right, to understand how they work and understand what are the limitations and where are they derived from, given the mathematical formulation of how these models, which are just functions, which take in some features and predict some others, about how they work. So you kind of need a bit of the math to understand what's going on there. Not like that. That's the kind of stuff that you could learn independently, though. So don't feel like you need to have a mathematical background or even a STEM background to learn that stuff, because it's really not that necessary. And we teach it, for example, on the job. However, so you may actually want to kind of use, you actually want to put machine learning into practice. You're not going to write your own algorithms. You're probably going to use libraries like sklearn or scikit-learn. And it's a Python library which has a lot of common and widely used in production machine learning models. So you should be comfortable with using that tool to pull out kind of all the standard pieces of the toolkit. And depending on your company, not necessarily for all or even a lot of companies, some companies may be applying deep learning. So traditionally kind of like more tech savvy, kind of ahead companies will maybe just kind of companies with like some interesting data format that's too complex to process with original algorithms. So maybe you've got like video data or something like that, even image data. That's these kind of places are where you'll be having to use more algorithms with a higher representational capacity. And so it will be useful to learn some deep learning framework, such as PyTorch or TensorFlow. Don't worry about which one, but you can see which one I prefer here by which one I've written. And then kind of once a data scientist has modeled some data, there come things like doing significance testing. So, how can we evaluate actually how good this model is? And then once you figured that out, and there's a bunch of techniques in there, which I can share if anybody's interested, but once you've figured out the result of that, kind of now what do we do with these results? And commonly for data scientists, that is going to involve stakeholder management. So presenting your results to other members of a team. They might be technical, they might be non-technical, they might be external. And so obviously a tool for this is, great communication skills, understanding how to present yourself, how to present your work, and how to kind of develop presentations or that kind of thing, and walk people through the narrative. Is there any questions about that? Take another 1 minute break. All right then. So the next, or maybe just to jump on Alex's point there about like, these are the kind of things, some of these things like a data analyst might do as well, right? So they may use may use some visualization tools, they may use some querying, but that would kind of be maybe a bit tangential to this main thread, which I'm covering, which is really about like, what do you need to get it into the real world?
Harry, sorry to interrupt. So just one question. So this regarding the data scientist who is building the model of using, say, sklearn. So is it that he's working on some model just to analyze the data, visualize the data, see the relationship, understand the statistics significance, or is it expected that this model, whatever he has evaluated, would also might be going for production?
Yeah, I mean, certainly could be both. Depends on kind of what the situation is, and kind of the roles I'm going to cover next. Like, I'm assuming that basically the data scientist has output some model which they want to put into production. So the next role is kind of ML engineering and MLOps, so really focused around how do you get that into a real product. But yeah, it could as well, you know, just be to understand like, oh, what's the you know, which directions are the biggest variance in our data, that kind of thing, or like even just to answer simple questions like who's our target user.
Sure,
great question.
Yeah, because I wanted to have some clarity between this part and what the MLE will be actually doing. So I'm more interested in the MLE part, but yeah, we'll see. Yeah.
Cool. Yeah, sure. Let's get through that. So ML engineering is certainly straddling between data science and the next role, which I'll talk about. So this is kind of one of the ones where it's like, well, is this really the right title? Is this just kind of because some people sit between those roles, or because those roles aren't well defined enough, or kind of companies aren't established enough to have someone who can do both? But to sum it up, I'd say ML engineering is about productionizing the work of data scientists. How do you take models which predict things that you care about and put them into real products? How do you actually like sew together the different parts of this pipeline? How do you connect the data to the model, that kind of thing? And then also kind of how do you optimize the model in terms of efficiency, both in like speed of training and speed of inference when it's in production, and also in terms of cost during training and production for that matter. So when I get to the ML ops, I'm basically, my key point there is going to say that the ML ops engineer basically sets up and builds and maintains the infrastructure which AI solutions are built from. The ML engineer's role is to kind of make the different parts of the solution work, optimize them, and improve them. So the ML engineer isn't necessarily for kind of creating infrastructure, you know, setting up databases, setting up the whole kind of system, but they're more for like using those services, understanding what the results mean, and kind of taking action to, you know, do the engineering and like build the product which the end user actually interacts with. Whereas the ML ops is more about the infrastructure that allow you know, data engineers, data scientists, and ML engineers to build on. So to go through what I've heard commonly ML engineers are doing, this is basically starting with testing. So using tools like PyTest, which is a Python library for running tests on your code, making sure it doesn't break in different instances, making sure it handles errors correctly, that sort of thing. I said here, putting the work of data scientists into the real world. So you know, ML engineers commonly are familiar with modeling frameworks like sklearn or PyTorch, and understand how they work, what kind of you know, support they need in terms of what kind of compute and libraries and that kind of thing. And then to my next point on responsibilities is to run experiments efficiently at scale. So, you may need some sklearn or PyTorch knowledge to understand, how do I make this more efficient? For example, how do I put PyTorch onto 40 GPUs at the same time? And commonly, to do that requires you to containerize these applications. That basically means put it in a format which will run on whatever computer you have, regardless whether it's a Windows computer or a Linux computer, and that is using Docker. So Docker is a tool for creating containerized applications. So yeah, really heavily used to put things into production. And yeah, I've also put down GPU acceleration here. And then the next kind of tool is like, going to talk about cloud services. And so really the ML engineers commonly are responsible for using different cloud services to do things, like I said, like training, or like kind of using different services to put together solutions. So that's why I've got this responsibility on the left, implementing end-to-end solutions. So you might use different, in this case, I'm just talking about AWS services. You might use EC2 to rent some computers in the cloud and do some training on them. You might use AWS SageMaker to, I'm saying you might. What I mean is commonly real companies do use SageMaker to deploy their machine learning models, to register their models, that is, keep track of which models were deployed when, what data they were trained on, and that kind of thing. SageMaker is also used for, can be used for training, although not always. It can also be used for monitoring, which is my final responsibility here, kind of tracking the predictions of the model over time, watching out for data or model drift or skew. That's what SageMaker is for. Yeah, just to reiterate that, SageMaker used for sometimes training, a lot of the time deploying, and sometimes monitoring machine learning models which are put into the real world using AWS. Basically, everywhere that I point out an AWS or just a cloud service, I'm basically saying, like, what that means is that other companies who may be better at it than you, like Amazon, can manage the service and mean that you don't have to worry about running servers or making sure your database is connected to the internet and that kind of thing. Another service which is commonly used to make these sort of end-to-end solutions is AWS API Gateway. So a common way, one of the two main ways to deploy a machine learning model is to build an API and basically expose particular endpoints, places on the internet where you can make requests to get predictions for some certain data, or you can send data there to make some predictions on it, that kind of thing. An API Gateway is a service, again, fully managed by AWS, that allows you to basically build APIs and kind of they expose kind of some particular interfaces to the real world. And on the other end, on the back, maybe you've got your SageMaker service, which is connected onto that on the back as a backend integration. Maybe you've got EC2, maybe you've got your databases on the other side of that API gateway. So that's kind of my summary of ML engineering. And I know that this one is a bit less well defined. So is there any questions about that?
So Harry,
yes, so,
go on.
Yes, go ahead. Yeah, I will.
I was just going to say, is it fair to say it's kind of like in a production, sort of a traditional production environment? So you design something, you check it works, and then someone has to build a lot of them. Is that kind of the relationship between data science and machine learning engineering?
When you say build a lot of them, what do you mean by that?
I mean, you've got a great product, but you actually have to deploy it to customers, and people need to be able to use it.
Yeah, totally. So kind of, yeah, ML engineering certainly brings in the deployment aspect somewhat. So yeah, maybe data scientists might hand over a model to ML engineer to actually expose this to real users, that kind of thing. Does that answer the question?
Yeah.
Cool, good. Does someone else have a question? I didn't see who that was.
Yeah. So I'm looking for mostly trying to get as an MLE I'm changing my role from database administrator to machine learning engineering, and this is my attempt to get into software engineer. So I'm trying to distinguish between the data scientist and ML engineer. So the data scientist builds the model, looks at the data, he thinks what could be the best model, and they experiment, and they finally tell, hey, okay, let's go with let's say random forest. Now, so as an MLE engineer, is it like I decide whether, let's say I decide to use PyTorch to implement or sklearn, and how I should use this framework optimally to put it into the production. So now I will have to use all those components, the Docker, the AWS cloud service, and everything to whatever production environment I have, if they are using this cloud.
Yeah.
Then I deploy that model. But apart from that model, there is also the whole pipeline, I think, should be going into the production.
Yeah,
because,
for sure. Yeah, cool. So I can start with the again, kind of these roles are pretty fuzzy, and I think the exact description, you should pay attention to what the exact description of the roles you're looking at is, because it could, depending on the company and depending on their stage, depending on how kind of tech focused they are, these roles could mean really different things. So just make sure to look into that. But in general, kind of ML engineering is less about the modeling, and it's more about putting them into production. So I have sklearn and PyTorch here, just so you understand, like, you should be familiar with them, because that's kind of what's going to get thrown over the wall to you. Hopefully not thrown over the wall, but kind of you're going to take charge of, and you should understand how it works. But yeah, you're absolutely right. The ML engineering is basically, as I've got here on the point 4 and the responsibilities, like implementing solutions, kind of making sure that you tie together. Okay, well, I've got my database, and I've got this model from a data scientist. Well, I'm going to put this model in a Docker container. I'm going to run it on EC2, and I'm going to set that up, and I'm going to make sure there's a connection to the database. And then I'm going to run a cron job so this like retrains every week, that kind of thing. That's the sort of end-to-end solutions that ML engineers might set up. And at the same time, kind of, oh, well, I've been past this PyTorch model. I can see that, we could get a 10% speed up if I were to, parallelize it in this way, or to kind of optimize the code in this way without changing the actual modeling aspect. I hope that helps.
Yeah, thanks. And I mean, if like I'm looking more for, my passion is in the computer vision and robotics. So I'm a little bit fuzzy on that part, like what, for example, if you have an auto car, then the car, when it is driving, it is looking at everything around it, and very quickly it has to make a decisions. So mostly they say that you need to use C++. So, but how now you got the skills, so you have the C++ knowledge, but you don't have much visual idea about what the company is expecting you to do as an ML engineer in such kind of scenarios.
Yeah, I mean, my ultimate suggestion would be try and talk to people in that position. So make sure to kind of connect with them, read their posts on Twitter, that kind of thing, and try and reach out to them and try and just get their opinion. I think a lot of people don't realize how responsive others can be. So definitely try and reach out to them. I'm certainly not an expert. And I think kind of with such a niche application, things might vary, particularly given what I'm talking about, because obviously I haven't mentioned anything about hardware here. If you're talking about robotics or autonomous driving, that's certainly going to be a constraint of yours. I'm going to move on just because we've only got 5 minutes left.
Thanks. Yeah, thank you.
No problem. Let me know if you've got any more questions as well. I can answer them after. The final thing I want to talk about is MLOps. So the responsibility of an MLOps engineer is to, MLOps obviously short for machine, maybe not so obviously, machine learning operations. So it's someone who manages the machine learning operations. And so this covers a bunch of things, but kind of at a high level, this is, I am setting up the infrastructure for everybody else to use so that we can do this at scale. So kind of to go through a few parts which are necessary there, when you're doing things that need to be repeatable, you need documentation. So an MLOps engineer is going to make sure either they're going to write, well, they have to write some parts themselves, but they're going to make sure the other teams have written documentation, so they know, okay, what's the best practices for containerizing our applications, what services do we use, how can you access the database, that kind of thing. And MLOps engineers are going to set up the cloud infrastructure. So they might come in and basically create images for Docker containers, which are reproducible kind of environments which this company needs for its particular application. And yeah, also kind of managing that infrastructure as an ongoing thing. So whereas an ML engineer may be just like, maybe they take a database which is already set up, they don't really have to kind of worry about the configuration. They can just use it as is, and they can kind of optimize whatever's sitting on top of that. They're not going to be the ones managing the database, managing maybe the costs, managing kind of the schema of the database, or any of the other services in a similar way. So to this point of these cloud solutions, I've got on the right hand side, one of the tools, the main skills is going to be like architecting cloud solutions. And so within that, there's a bunch of different cloud technologies which are commonly used to build AI solutions that work at scale. So that shouldn't say AWS Terraform. Terraform is not an AWS product, but it should say AWS CloudFormation. These two tools, they do the same thing roughly. And what they allow you to do is basically just specify your whole end-to-end solution as a config file. So you can configure, you can kind of like say in that file, you can say, okay, cool, my first part is this database, my next part is this this server in the cloud, my next part is AWS SageMaker, and then it's going to dump the results into an S3 bucket, that kind of thing. So you could set up that configuration in passing config file to say AWS CloudFormation, and that would make it very repeatable and not so prone to human error. Another service here, kind of EC2, using compute in the cloud. API gateway I've already mentioned, or otherwise using Flask, which is a server for is a Python library for building APIs if you want to build something from the ground up. SageMaker, I've also mentioned the ML engineering. Now, Kubernetes here is basically a software which you can use to deploy applications in Docker containers. So you have a particular model, you put it in a Docker container, you have that then running on one computer. My question is, what if I have suddenly 100x the request than usual? I'm going to need probably more than just this one container running the code. So what I'll do is I'll use Kubernetes to automatically scale up and scale down the application as I need it. And Kubernetes is not just a machine learning tool, it's for kind of all sorts of applications that you can imagine have similar constraints. Kubeflow is a service which sits on top of Kubernetes and is specifically for machine learning. So it's for managing your machine learning applications, making sure they scale. And the tool in this I'll just mention quickly, which is Kubeflow pipelines. And that's similar to this other tool, Airflow. What those two things, Kubeflow pipelines and Airflow, do is they what's the word I'm looking for? They orchestrate a series of different actions which need to happen. So, for example, you might need to, okay, every week we are going to kind of retrain our model. Maybe that's the problem. You could use Kubeflow pipelines or Airflow to set up a sequence of actions which will make that process happen. So, for example, first step is we read in the data from S3. Next step is we transform the data using this ETL procedure. The next step is we put all of that into a database. The next step is that we connect our AWS SageMaker model to that database and train on it. And then the next step is that we take the trained model out of SageMaker and we put it into a Docker container and we deploy it all over Kubernetes. That's the kind of process that you might want to set up you might use Kubeflow or Airflow for. And what that links to is what I've got on the bottom left here, CI/CD/CT. So you may have heard of CI/CD. That stands for continuous integration, continuous deployment. So that might be like, that's basically kind of things that you can set up using GitHub Actions. So for example, every time I push to a Git repo, I'm going to redeploy the website. In machine learning, I have this CT, which is continuous training. And what you can do is you can use monitoring infrastructure like Prometheus and to pull in different metrics about how your model is performing, and then use those to trigger retrain when the model drifts too far from how accurate it was previously. That kind of thing. And then, yeah, just one of the final tools I'll mention is Grafana, which is a commonly used tool for taking stats about how your services are performing from Prometheus and graphing them. Yeah, so I know we're tight on time. We just overrun a little. Is there any questions about MLOps? This one may be more foreign to people, but this is getting really hot right now. MLOps is getting really hot. It's going to be a sexy job in 1 year.
Yeah. Hello.
Hey.
Hiya. I was just wondering about the course. Could you tell me a bit more about that?
About the course, yeah.
That you guys offer.
Yeah,
I just checked out the website.
Yeah, totally. So I didn't actually really do a good job of explaining what we do at the beginning of this event. But basically, I'm one of the founders of AI Core. AI Core is a vocational AI and data school. We train in all the skills that I've just mentioned through an 18-week program and then get you hired. In short, we're an end-to-end solution to launching your career in AI and data. We don't just include the technical skills training, but we take you through our playbook to get you recognized in the industry. That's kind of the next part I would have gone on to talk about at the time, to get you recognized. We help you find your niche within the field and make sure your CV gets you to interview, and then make sure that you're confident and impressive enough to pass those interviews. And I could go on and on about all the things that we do, but the best way would probably just be attend the Q&A, the program Q&A next week. So next week we've got another event, which is basically going to talk all about the details of the course we run, which, as I said, covers all this stuff and kind of more about the recognition. So if you want to find out more about that, please attend. I'll just skim through kind of these points in like 20 seconds. People got to know who you are, so you've got to get recognized. Increase your luck by getting exposed to more opportunities and get yourself out there. These are some of the things that you can do to increase your recognition, work on blogs, work on projects, and join communities and talk to people. How can we help you? You should check out the event. I'm going to leave it there, guys, because I've got some of my students have got to go to class now as well. So is there any other questions I can answer just to close up?
I have a small question. Do you think that MLOps to future with web development, or do you think it's something that is very far from that department?
So sorry, what did you say?
What I'm saying is, do you believe that an ML engineer would need to have web development skills, or do you think that's something unrelated to that position? Yeah,
you don't need web development skills to do any of these jobs. Some companies think it's like a nice to have, but that would only really be if you are kind of at like a small company where those roles are kind of done by similar people. But yeah, in any established company, they're very different roles. Even software engineering is kind of very different to any of these roles I've mentioned today. Great question.
Thank you very much.
No problem. My pleasure. Is there anything else I can answer?
Hi, can you hear me?
I'm going to stop sharing then, and I will. I'll let you all go. Yeah, we'll send out an email with follow-up, and yeah, we'll share more information about the event which we're running next week, where you can find out more about what we're doing aside from this, or if you're interested in actually learning some of those skills. or going through the playbook yourself. I'm sure some of my students here would give a shout out to how great it is. But yeah, other than that, guys, I'll leave you to it. Have a good
Thanks,
night.
Harry.
Let me know if I can answer any more questions.
Cheers, Harry.
Thanks, Harry.
Thanks, Harry.
Thank you, Harry.
Hey, Harry, I have a final question. Sorry to catch at the last minute. I remember you said that you have the file that recording like each company use different software. Like this company use Python, that company prefer use R. Would you mind to share that file? How can I get this file?
Yeah, if you want to email me, I can share some information with you.
Sorry, I can't hear very clear. What you say?
If you want to email me, I can share some information with you.
Oh, sure. Thank you. Thank you.
Harry at the end.
Thank you.
All right, nice one. Thanks for attending, guys. I'm gonna head off. I'll see you all soon, I hope.